There's this old myth that the Great Wall of China is the only human structure that's visible from the moon. So in this video, we are going to try to evaluate this claim by doing very simple calculations and try to demystify this myth. Okay, let's go. Already, the Great Wall of China is really an impressive architecture. It has really amazing dimensions. It has a width of around 6 meters, okay, and a total length a whopping 21 kilometers, around 21 kilometers. I think it's a bit more, but yeah. So it's really impressive, the dimensions of this wall. Imagine really a wall that has 6 meters width. That's really thick. That's really impressive. So the real question to ask ourselves here, and what we want to evaluate, is, can a structure that has, I'll just represent really something rectangular, can a structure that has a width of 6 meters, okay, and a length of 21 kilometers be seen from the moon? That's really the question we are trying to answer here. Okay, the first thing to be taken into account here is what the human eye can see, okay? Because if you stand on the moon, what can you see? The eye is like an optical device, okay? It has a resolution. It can't just see anything. So we need to first take into account what the human eye can see. So the resolution or the resolving power of the eye. So resolving power of the eye. And you can easily check that on online sources. That's around 0.017 degrees, approximately 1 arc minute. So this is the resolving power of the eye, which means it's the minimum distance, okay? So suppose you're standing here and you're using your eyes to observe. Then imagine you have 2 points, okay, A and B in space. Then what this means is that they need to be at an angle of at least this value for your eyes to be able to distinguish them, to be able to see them as two separate points. So this is what we mean by the angular resolution of a camera, in this case of the eye. So we are just going to calculate the angular size of this wall as seen from the moon and see how it compares to the resolving power of the human eye. So let me just make a small sketch. So let's assume here is the moon. So let's say here's the moon and you're standing somewhere here. I'm not very good at drawing. Hope that works. So let's say this is the moon and here we have the earth, of course, which is much bigger. Oops, okay. My diagram is not that bad. So let's say this is the moon, this is the earth, and that we are looking at the Great Wall. Well, we are supposedly looking at the Great Wall and see if we can identify it. So let's say this is the wall, okay? So the distance between the earth and the moon, let's call that D, is around 384,000 kilometers. So in order to be able to see an object, when you have an object that has a length and a width, a two-dimensional object, in other words, what matters here is the thickness of the object, okay? Why is it so? Because if you can't see the thickness of an object from far, you won't be able to see its length. So it's really logical. To be able to clearly see an object, you must see both dimensions, okay? If you can't see one of the dimensions, you can't see the other one. It's really That's really the simple logic and the simple thing to grasp here. So in this case, our world is rectangular, so we must be able to resolve each dimension of the object, else we won't be able to see the object. So in this case, let's see if we are able to resolve the smallest dimension, which is the width in this case. So what your eye is going to see, so let's draw two lines. Okay, so here I've just drawn the lines of sight. So let's call this angle here theta, okay? And this small length here represents, let me use another color, and this represents the thickness of the wall. So let's call that W. So this is the thickness W. And the distance between the two, the Earth and the Moon, is 384,000 kilometers. So let's calculate theta, which is the angular size of the width of the wall as seen from the Moon. We can just use a trigonometric approximation, which is that the tangent of theta, okay, if theta is small, then the tangent is approximately equal to the width divided by the distance between the two points, which is d. And for small angles, tan theta is approximately equal to theta. So theta here can be calculated as W over d. So if we plug in the values, we have 6 meters for the wall divided by d, which is 384,000 kilometers. So convert that to meters, we have this. And if we perform this calculation, you're going to have around let me put that maybe in green. You're going to have about 8.95 times 10 to the negative 7 degrees. So what you can notice is that the angular size, okay, of the width of the Great Wall seen from the Moon is much smaller than the resolving power of the eye. You can clearly see that it's orders of magnitude smaller, which means we won't be able to see the width of the wall or the thickness of the wall, and consequently the length of the wall. So theta of the wall is much smaller than theta of the eye. So the eye, in other words, the eye won't be able to resolve this. It's impossible. So myth debunked. Okay. So whenever you hear someone again say that the Great Wall of China is visible from the Moon, you can first redirect him to this video, okay, so that I get some views. And you can tell them that it's just a myth, okay? The calculations are really simple and it's just not possible. It's clearly impossible to see that the world from space. Okay, so if you find this interesting, drop me a like after subscribing, of course, and then point your comments or remarks in the comment section. I'll be glad to read you. Let's discuss about this. And yeah, I see you in the next video.